I think I'm going to make just a single video for topics 4 and 5 again. They're both pretty short. They're very similar. So we'll just do one video for those two topics, okay? So for topic 4, we're going to look at sales tax, okay? So sales tax is a percentage of the sale price of goods or services that is collected by the seller and then paid to the government, okay? So we have an equation. So when you're dealing with sales tax or when you're dealing with discount, you can solve using an equation or a proportion. Um, because this is kind of, we've done more algebra than not, we're going to focus more on the algebraic method. So we're going to look at the sales tax equation. I can show you the sales tax proportion, but we're not going to use it as much for this video. Okay, so I'll show it to you once and then it's up to you if you use it or not. Okay, so the sales tax equation is that sales tax is equal to the cost of the goods times the sales tax rate. And what I want to let you know here, this is really important. The sales tax rate is a percent that we convert to decimal form for the equation. Okay? So you're going to be given the sales tax rate as a percent, and then you have to convert it to a decimal and then put it into this equation, okay? Now, sometimes you're asked for just the sales tax. Sometimes you're then asked for the total cost of the goods. So the total cost of the goods is the sales tax plus whatever the pre-tax cost is. So whatever the cost of the goods or services before tax plus any sales tax, that's what you actually end up paying. Okay? So let's look at example 4. Example 4 here says solve each tax. It should say sales tax. Oh, it does. Yeah. Solve each sales tax problem. Include correct units with each answer. Okay. So it says here Elizabeth bought new towels and sheets for $65. How much did she pay if the sales tax is 6%? Okay. So remember, we have sales tax equals the like pre-tax cost of the goods times the sales tax rate. So we don't know what the sales tax is actually going to end up being, so that would be our unknown here. So we would assign a variable to sales tax, and then we would fill in the other information. So the cost of the goods before tax is $65. And then we're going to multiply that by the sales tax rate, which is 6%. Now, 6% is equal to, remember, move the decimal to the left twice and drop the percent symbol. So 6% is equal to 0.06. So we're going to multiply 65 by 0.06. All right. If you have a calculator, you can multiply that out pretty easily. So 65 times 0.06 is 3.9. But remember, the direction said include correct units with your answer. So of course we need to add a dollar sign, okay? Because we're certainly talking about money here. But we also want our answer to look like money. And anytime you're dealing with money, and we're going to do that quite a bit in this chapter, okay? Because personal finance is all about money, okay? We always want to make sure our answers have two decimal places unless we're told otherwise. So you would never go to a grocery store and see an item that costs $3.9. It would be $3.90. So make sure you write this with two decimal places, okay? So we would say $3.90 in sales tax. So correct units and then just give a quick description of your answer, okay? Now, if you are interested in doing the proportion, okay, you could do a proportion here. So we would get sales tax over the cost of the goods before tax. That's going to equal the sales tax rate over 100. But I do need to give you a warning. If you do the proportion, leave it as a percent. You don't have to convert it to decimal form, okay? Because we're dividing it by 100, that's why, okay? So we would say x over 65 equals 6 over 100, okay? So remember, we leave the sales tax rate as a percent when we're dealing with the proportion. We cross multiply, so I would get 100 x equals 6 times 65. So let's see what 6 times 65 is, 390. Divide both sides by 100. 100 divided by itself is 1, and we get x is 3.9, or $3.90. You get the same answer regardless of the method you choose, okay? I want to show you the proportion method just this once so you can kind of see how it works. But for pretty much everything we're going to do the equation method, which is what's at the top of this box, okay? So sales tax equals the cost of goods times the sales tax rate, okay? Now, in the next example, we're going to do two parts. So for part B, it says Joe bought new clothes for his bank job. Before tax, his total was $180. What will Joe pay after 5% tax is added to his purchase? So we're not just calculating the sales tax for part B, we're calculating the sales tax, and then we're going to go ahead and add that to the cost of the goods so we can figure out how much Joe actually pays at the register because he's paying for the cost of the goods plus that tax. Okay? So remember, sales tax equals the cost of goods times the sales tax rate. We don't know what the sales tax is, so we're going to let that be our variable. So X equals the cost of the goods before tax was $180. The sales tax rate is 5%. So 5%, remember, to write it as a decimal, we drop the percent symbol and then we move the decimal to the left twice. So we get 0.05. So 180 times 0.05. On a calculator, you could just multiply the 180 times 0.05, and I get 9. Okay, so this is $9 in sales tax, but that's not actually answering the question. The question is, what will Joe pay after 5% sales tax is added to his purchase? So how much does he actually pay at the register? Well, the total cost equals the cost of the goods plus sales tax. So the cost of the goods in this case was $180. Plus he's got to pay that $9 in sales tax. So at the end of the day, Joe pays $189 total. And in this case, since you're dealing with a whole number, you don't have like a decimal, you don't have change. You can just leave this as 189 flat out. You don't have to write 189.00, okay? But if you have any kind of decimal, it does need to be two decimal places, okay? So there's potential for rounding or potential for adding zeros, but you always want two decimal places if change is involved. And by change, I mean like dollars and cents change, okay? Now, that's it for topic 4, so that's sales tax. For topic 5, we're going to understand discount, okay? So discount is a reduction in the original price of an item, usually expressed as a percentage of the original price, okay? So we have a discount equation, and the discount is equal to the original price of whatever the item is times the discount rate. And again, discount rate needs to be written as a decimal if you're using the percent. All right, if you use the proportion, you don't have to convert your discount rate to a decimal, but here we're going to convert it to a decimal. Okay, now you could also be asked just what is the discount? Like how much is this price going to be reduced by? The second thing you could be asked is what is the sale price? Okay, so the sale price of the goods is the original price minus whatever the discount is. So minus the value of the discount. Okay, so let's see what we have here. Example 5 says solve each discount problem, include correct units with each answer. So remember, discount equals original price times a discount rate as a decimal. Okay. So we know that a jacket is on sale for 25% off of the original price of $65. So we know the original price is $65. What is the sale price of the jacket? Well, we have the original price, we have the discount rate. What we don't have is the actual value of the discount, okay? So the discount, that's going to be our X, that's the piece we don't know, is going to be equal to the original price of the jacket, which is $65, times some discount rate, okay? Well, our discount rate is 25%. And remember, to take a percent and write it as a decimal, we move the decimal to the left twice and then drop the percent symbol. So this would equal 0.25. So we want to take the original price of the jacket and multiply it by 25% in decimal form. You can do that on a calculator. So 65 times 0.25, I get X equals $16.25. This right here is not the sale price of the jacket. This is the value of the discount. So this is how much they're going to take off of the original price of the jacket. So the question here says, what is the sale price of the jacket? We've got to do a little bit more work. So remember, the sale price is the original price. Well, I forgot a P. I forgot R. I mean, original price minus whatever the discount is. And we know what the discount is. That's the $16.25. So what we want to do is take the original price of the jacket, which is $65. We want to subtract 16.25. You can do the actual subtraction on a calculator. And I get 65 minus 16.25 is 48.75. And I'm just going to put sale price so that I know what that number means. And that's it. Okay, so just be really careful with these problems. They're not terribly difficult at all. Just be careful when you convert your percent to a decimal. I do encourage you to use the equation method, not the proportion method, just because we've been doing more algebra in this chapter. Okay, but make sure you answer the question that is being asked. If it wants the sale price or the total price versus just the sales tax or the discount, make sure you give the correct answer. Okay, now Part B says, due to a hailstorm, a local dealership, hold on, I gotta move a picture out of my screen. Due to a hailstorm, a local car dealership was forced to discount some of the cars due to hail damage. What is the sale price of a car that was originally $21,700 but is marked down by 15%? So remember, discount equals original price minus the discount. And so what we do is we acknowledge that the discount is the piece we don't know. We know the discount rate, but we don't know the dollar value of the discount. So we're going to say the discount is X. The original price is 21,700. Oh, wait. Was anybody going to yell at me? Like, do you all sit at home at the computer and scream, wait, no, you made a mistake? I made a mistake here, y'all. Okay, let's start this one over. So we know that discount, the actual dollar value of the discount, is equal to the original price times the discount rate. I'm so sorry about that goof. All right, the discount is what we don't know. We don't know the actual dollar value of the discount, so we're going to say it equals X. We do know the original price of the vehicle is $21,700, and we want to multiply that by the discount rate. This car is being reduced by 15% of its original price, so 15% equals 0.15. So when we do this multiplication, you can certainly use a calculator to do the actual multiplication. So 21,700 times 0.15, I get 3,255. So what is this? This is the value of the discount. This is how much the original price is going to be reduced by. So this is the value of the discount. Now what we need to do is find the sale price. So the sale price is the original price minus the discount. So the sale price is going to equal 21,700 minus the dollar value of the discount. And the dollar value of the discount is right here. So we want to subtract 3,255. So that means we just do the subtraction on a calculator. So 21,700 minus 3,255. That means we would actually pay $18,445. And that's our sale price. Now, just for fun, let's kind of explore. If we're dealing with a car, okay, and we know 100% of the cost of the car is $21,700, and we know the car is being reduced by 15%, what percentage of the price of the car are we actually paying? Well, 100 minus 15 would be 85. So at the end of the day, if we're getting a 15% reduction, we're paying 85% of the original price. So just for fun, my dog is about to lose her mind. Maybe not. So just for fun, what is 85% of the cost of the car? Well, if I took the cost of the car and multiplied it by 85% as a decimal instead of 15%, let's see what we get. So let's go to the calculator. Ooh, where is the calculator? Is it here? Nope. Let's find the calculator, y'all. It should be here. I picked the wrong screen. Okay, so we want to go here. So we had a car that was originally 21,700. We know it was being discounted by 15%. That means we're paying the remaining 85% of the car. So if I took 21,700 and I multiplied it by 85% as a decimal, so 85% as a decimal would be 0.85. What do you notice here? Okay, so if I took 21,700 and I subtracted 18,445, I get the discount. So it's kind of cool how these discounts work. They sort of work, I don't want to say in reverse of each other, but if you know your discount rate, you can figure out how much of the price of the car you're actually paying for, and then make this a one-step problem. Tread lightly, okay? So anyway, that is sales tax. That was topic 4. Oops. That's sales tax, and then now discount. With these problems, I would encourage you to use the equation method, not necessarily the proportion method I showed you, for example, for part A, but you could use the proportion method. Just make sure you answer the question that's being asked. If they want a sale price versus a total price with sales tax, make sure you answer that. So just read your questions very, very carefully.